Good evening all, and welcome to today's session of the Institution of Naval Architects. Today's session is on energy efficient design and operation of ships. The chief guest for today's session is Dr. H.N. Das, Associate Director, NSTL, and the session is chaired by Mrs. Sapna Dipu, AGM of Mazagon Docks Limited. Today's presenter will be Professor M.S.P. Raju of AMET University, who's got varied experience in education, survey, as well as in ship research. With this brief words, I invite and hand over the session to Mrs. Sapna Dipu, who is the session chair for the session. Mrs. Sapna Dipu, ma'am, please.
Thank you, Mr. Raju. Good evening to all. See, I started on a for the technical section. Topic.
I'll just introduce Ms. Sapna Dipu. Ms. Sapna Dipu is the Additional General Manager with the Mazagon Docks Limited, and she has put in 28 years of service in the design office of the organization. She is a naval architect from Cochin University of Science and Technology and holds a Master in Ocean Engineering and Naval Architecture from IIT Kharagpur. At present, she is heading the Forward Design Group and Contracts and Marketing of Mazagon Docks. With these few words, ma'am, now you can take over the session.
Thank you. So, the today's topic we have selected for the session, design and operation of ships, is one relevant area to be used in the present scenario. I have no doubt that the chief guest and the presenter today will be handling this very efficiently. Without the chief guest, Dr. H.N. Das, Associate Director, in civil engineering from Jadavpur University and completed programming structures from the same university in 1991. This PhD from IIT Delhi in 2009 years. He is working for DRDO and is in establishing a CFD group, Naval Hydrodynamics at NSTL. He worked for and witnessed the development of field of CFD hydrodynamics in India right from its early years. He carried studies for ships, marines, torpedoes, and their propellers, including maneuverability, simulations, multi-phase flow to modification, and free surface, etc. At present, he is director at NSTL, project director for high autonomous water vehicle. For Andhra University, invited colleges, universities, and research institutes in India. His recipient Sapna bronze medal from Jadavpur University, Institution of Engineers, of Marine Engineers. He's Journal of Engineering Application of Computing Fluid Ocean Engineering, American of Naval Engineering, and has more than 50 publications in conferences and repute. I don't think that's for anyone else to be the chef of the webinar. First, Dr. H.N. Das to provide the operative mark.
Thank you, madam, for giving nice introduction for me. Professor M.S.P. Raju, presenter of today's program. This is Sapna Dipu, AGM, Mazagon Docks Limited, Dr. Bhardwaj, Srinivasan Nayangar, and all the delegates and members present for today's occasion. I feel this is indeed a privilege for me to join this occasion, and I have a special pleasure because my old colleague Professor M.S.P. Raju is the presenter today, and in this way actually I got an opportunity to meet Professor Raju, with whom actually once we have shared our room in the same building and worked together at NSTL. At the outset, I want to congratulate INA for taking up such a initiative, and I understand INA is periodically holding this type of presentations, though I was not very much associated with that, and since a long time, almost like 7-8 years, I have not attended any of the functions from INA, and that may be a drawback from my side. And that is the more the reason I congratulate that INA is doing this type of programs. And energy efficient design and operation of ship is a very relevant subject for today's scenario. And I actually, when I heard about the topic, I felt very thrilled, and I'll just go through it and see Professor Raju how he presents this energy efficient design and operation of ship. As such, ship design is a very old, very traditional thing present in many years. Before the engineering came in practice during the industrial revolution or anything, the ship design, the sailing of ships were there, and it is a very traditional thing, has lasted many decades, many centuries. Of course, the mechanization has dramatically changed with the advance of industrialization. All the propeller and mechanized ship theories has come, and we have seen the progress of progress of this ship design. And recently in the 20th century, again, we have seen the advance of computational sciences, and how computational science has facilitated or given ease for the design of ships. And in fact, computation has aided all the fields of engineering. There is going to be again a change, like industrial revolution. When mechanization came, there was a change. With the computation, there is again a second set of changes coming for the design of any engineering field. Ship design is also not an exception. And with the advent of computation, computational fluid dynamics, many shipyards like these Koreans and Japanese shipyards, which has grown with this advance of CFD, is now coming and competing with the European shipyards, which are traditionally established for many long years. So this is another sign of progress along with CFD and ship design. Because I have worked in CFD, so this is a little bit of a soft corner I have for this area, especially. And the energy efficient design is the need of the hour for any design. And without spending much time on that, I request the Professor Raju to take it on with this program. Thank you.
Thank you very much, sir, for setting up pitch for the technical session. We move on the session. We hear Professor MS Raju, Dean, PG Studies, Director, Naval Architecture and Operations Department, AMET University, Chennai, as our presenter on the selected topic. Professor is graduate in Naval Architecture from Andhra University and a PhD in Ocean from IIT Madras. Also, he has 8 years of experience in industrial research and teaching. 8 years as ship surveyor with NV. Then he joined India Shipping Company in Mumbai as ship superintendent. He has almost 50 years as part of hydrodynamics and ship studies. He also has an inclination towards teaching, imparted his knowledge to students throughout, and now he's following his third PG studies and direct architecture and department. We have to about the energy efficient design and operation. To you, Professor Raju, for taking question.
Thank you, madam. Visible slides are visible, madam.
Slides are visible. You can
It
just
is
put it in
visible
full
from my
screen and
side.
go ahead.
Okay, now I can. Okay.
You can just put it in full screen and go ahead, Mr.
Yeah.
Raj. Yeah. Now it is in full screen. You can just proceed.
Yeah. Good evening, one and all joined for today's presentation. Today's topic is like energy efficient design and operation of ships. So the reason behind choosing this topic is because of my experience in my previous organizations. Like I worked almost all a decade in the naval research, especially in experimental hydrodynamics, where I have worked on various types of crafts like high-speed crafts and various other model testings for various other ships. And later, when I worked in DNV, Diagnostic Veritas, as a senior ship surveyor, I was the part in what do you call advisory division for the energy efficient ships inspection and surveys. And now, as you all know that IMO, International Maritime Organization, is keenly working on this energy efficient design and operation of ships. MARPOL, that is Maritime Pollution Regulation, Annex 6, basically discusses this topic in detail. So now let us see that in today's my lecture, I will be covering in the design aspect what all we can do so that energy efficiency is achieved, and in the operations area also what we can do so that the energy efficient operation is achieved. So these are the two topics basically. One is energy efficient design and energy efficient operation. Now, when we say energy efficient here, the main idea is reduction of greenhouse gases emission, especially carbon dioxide emission. If you see that CO2 emission from the ships, it is only 3% of the total transportation. All industries, you can see that international shipping was only 2.7%. And it varies from year to year. I think now presently it is 2%, something like that. So even then, even though our what do you call share of CO2 emission is very less in the entire this thing, but still IMO has taken up as a what do you call precautionary measure from the shipping industry. We have to address this for the sustainability of the globe. Now, a very important thing is, as you all know that EEDI, that is Energy Efficient Design Index, Energy Efficiency Design Index, which was mandatory from 2013 January for all the new design ships. So here, basically the concept I will explain here. The EEDI basically is talking about the harm the ship is doing to the environment and the benefit it is doing to the society, that is the transportation work. Now you can see here, this is the harm it is doing to the society. Meaning is what? That is the carbon dioxide emission. And what is the benefit it is doing to the society is this, that is transportation work. So the power multiplied by the specific fuel oil consumption multiplied by the conversion factor, it will give you basically that how many grams of CO2 it is emitting when it is transporting a ton a nautical mile distance. These are the units. grams of CO2 when it is transporting a ton, traveling a nautical mile, EEDI. So this is a technical measure. EEDI is a technical measure. That means during the design stage, that means before construction itself, the EEDI has to be established. Then what is EOI? That EOI is Energy Efficiency Operational Index. This is an operational measure. That means what actually is happening. From there, what is the carbon dioxide emission? If you calculate, that is EOI. Actually, this is part of SEM, that is Ship Energy Efficiency Management Plan, which is mandatory as far as this IMO regulations are concerned. So EOI is part of SEM. Now here, if you see that how we calculate EOI is, what is the actual like fuel consumption? Generally, what ships will do is noon to noon data they will have. That means from today's 12 o'clock to tomorrow's 12 o'clock, how much fuel it has been consumed if you have the data, and multiply with the conversion factor. Basically, which talks about how many like tons of carbon dioxide emitted when 1 ton of fuel is consumed. That is what fuel consumption multiplied by conversion factor, and divided by dead weight. That is a capacity, how much it is transporting, and distance, how much, what is the range it has traveled. So it is EOI is an operational measure. Now 2023 January, that means after 10 years of EEDI operation, now IMO has come up with a new one, that is Energy Efficiency Existing Ship Index. That means for all the ships, basically above 400 GT, all the ships are like, they have to meet this requirement, Energy Efficiency Existing Ship Index. The calculations and all are same, like EEDI only. So this is EEXI is the measure of like technical measure. That is the technical measure. And then CII is what you call the carbon intensity indicator. Okay. So this is a operational measure. So again, this is also like what is the total CO2 emission, and then what is the capacity, that is dead weight, and travel distance. So these two are very, very important right now. And now we will see that how it is done. Now take EEDI. EEDI is basically like, see, we have on the x-axis dead weight, and on the y-axis is EEDI. So IMO has given required EEDI line, that is like phase 0. Phase 0 is 2013 to 2015 is the phase 0. So it has given, yes, your ship should have this EEDI. But basically, we should have lesser than that. Now, example, let us say, if you are going ahead with a 1 lakh deadweight vessel, when you calculate for your vessel that is attained EEDI, that value should be below that line. Okay, so that is important thing. Generally, what we think of in general design and all, what is the required and what you have attained, that should be more than that. But in this case, what happens is, since it is a negative factor, that is carbon dioxide emission, that required EEDI and attained EEDI should be lesser than the required EEDI. But now another important thing is, that is for the phase 1. But as phases are going like phase 1, phase 2, phase 3, that means from 2015 to 2020, the phase 1, 20 to 25 is the phase 2, 25 above is phase 3. So like that they are given. but every phase they have reduced requirement 10%. That means this is the next line, and this, and another is this is another line. So that means an young naval architect now, whoever is coming or whoever is in the design sector now, when they're designing after 2020 or after 2025, he has to check with in which EEDI phase the vessel is coming, and accordingly his EEDI value should be meeting that requirement. Okay, so but actually, in fact, the phase 3 has been brought forward now. Now already we are in the phase 3 from 2022 onwards. We are in the phase 3. Okay, this is as far as EEDI is concerned. Same with the EEXI also for existing ships, whatever it is, the formulation and all the same only. Now coming to the EOI operation, you can have the data of like every voyage. What is your EOI? You can calculate. And then the shipping company will decide what is the KPI, that is your key performance indicator, KPI to achieve in the maybe next month target. So they always fix lesser than what they have achieved in the last month, maybe less like that. So this is part of EOI. So now I have explained so far, like what is the requirement and what is the necessity of understanding this energy efficient design and operation, because it is a statutory requirement to meet EEDI and EEXI and CII. Okay. Now let us go to the energy efficient design part. How do we achieve this? Now in the formula, we have seen that the power is very important. Right? We are using the term power, engine power, that is installed engine power. Generally, we use in that formula like 75% of installed engine power. So now in the new designs, our target is how do we reduce what you call the power requirement, the installed engine power. That means we have to design the ship in such a way that it requires lesser engine power. Okay, so then the EEDI value is good. So now for that, these are the options available. One is we have to design the hull form in such a way that we can minimize the resistance, and we can design the propeller to maximize the thrust, and by using various performance improving devices. So this is the way, this performance improving devices, we can use it for existing ships also. So whenever a ship is coming for dry docking, people can go for this improving devices. These we call as EIDs, energy improving devices. We can add to the vessel, and then thereby we can reduce the fuel consumption, thereby carbon dioxide emission. So now let us see that how each one works. Now the idea is we have to reduce hull resistance, right? Now, as we all know that if you see that basic broad classification of our ships, a little bit lower speeds and a little bit higher speeds sort of thing. Basically, whether it is a low speed or high speed, as we all know that we don't just decide by the speed in knots, but we will decide generally by the fluid number, right? So now for the low speeds, like bulk carriers and tankers and all, which resistance component is dominating? That is the main important thing we have to understand. So the main thing is frictional resistance. For the low speed ships, frictional resistance is the dominating one. Hence, our strategies should be how do we reduce the frictional resistance? That is what any naval architect should work. And suppose if a little bit higher speeds like containers, generally containers will move at comparatively higher speeds than bulk carriers and tankers. In this case, mostly sometimes wave making resistance also dominates as the speed is high. Hence, the strategy should be reduce wave making resistance. This is a broad classification, right? Even for the bulk carriers and tankers also, we have wave making reduction techniques also. It is not like that, right? Now, just for a quick revision, here is the what are the various components of the resistance we have, like frictional drag, form drag, wave making drag, eddy making resistance, appendage resistance, air resistance. So now our idea is how best we can reduce these resistance components by adopting maybe latest techniques, latest technologies, or whatever knowledge we have. By using that, can we reduce these components so that the effective resistance is less, thereby the engine, that installed engine power is less, thereby the carbon dioxide emission is less, thereby EDI is less. EDI is achieved. That is what our topic basically today. Now, I'll be explaining some of the well-proven technologies right now available. One is basically this is for the frictional resistance or frictional drag reduction, introducing air film along the bottom of the hull to reduce the skin friction drag. Okay, so to reduce the skin friction drag, introducing the air bubbles down below. So literature says it is giving 10 to 12% drag reduction, right? But at the same time, we should not take it right away. Oh, 10 to 12% is not like that. Everything has to be verified by model testing, and then maybe CFD, computational fluid dynamics, or whatever numerical techniques we have. And another important thing is like bulbous bow. Okay, so this is what our a gooseneck bulbous bow. So bulbous bow is used to reduce wave making resistance. This is a very important point, right? It used to reduce the wave making resistance. That physics and all behind, we know that how it reduces wave making resistance by wave interference method. So literature says that it also reduces 10 to 15%. But one more important thing we all know it also, or we need to know is the bulbous bow, whatever we have designed, it is applicable for that design draft, for that design speed. That is important point. Maybe with some other draft, maybe with some other speed, it may be a little bit adverse also, right? But generally, most of the time, the ship moves at the design draft and design speed. Considering that, we have to design the bulbous bow. And we have many types of bulbous bows. We have in theory also, we say in general, like we have delta bulb, we have nabla bulb, right? And we have circular bulb. So based on the type of section we are using in the forward, we have to go decide the what type of bulbous bow we are going to select. And next important one is aerodynamically designed superstructure. This is also a very important one. This aerodynamically designed superstructure, right? Because generally in our naval architectural model resistance test and all, we don't bother much about air resistance, because compared to this water resistance, that is very less component like that we think. But based on the superstructure and all, and then freeboard what you have, if you can streamline the superstructure aerodynamically, then it will reduce resistance. Okay, so but here we have to take important decision, like a trade-off, design for production and design for efficiency, right? Which one you want, right? Because why I'm saying is, shaping this curve, you need more like the time and money and all those things. So that is a design for production thing. But at the same time, even if you spend a little bit money at the initial stage, what is the benefit it is giving throughout the life of the vessel, right? So that what you call economic study one has to do before going for this. Bharadwaj, I think everything is clear and loud. Hello.
Absolutely.
Yeah,
Sir, Raju, it is fine.
yeah, okay. Because I'm keep on talking. If it's a physical class means I would see the people and talk like that. Now this is as if I'm talking to the wall. Only it is there. Okay, right. Now coming to the ductile, it is another concept. This is what like a ductile, like virtual lengthening of the water line. Okay, so if you increase the water line length, it is having its own hydrodynamic advantages, right? So it reduces the drag, and then literature is telling that a 5 to 10% less power demand when you use this concept ductile. Very, very important. Like generally in model testing also we do that flow visualization tests, right? So any opening you are giving or any appendage you are adding onto the hull, that has to be substantiated with the flow visualization test results, right? So this is very important, the flow, the direction. So it is beneficial to install a scallops behind each opening to reduce the drag. Okay, so that the proper flow and all there. So this reduces drag by 5%. Then now onwards, like see, these are like what you call energy improving devices, EIDs, right? So this is what we call propeller boss cap fin. Propeller boss cap fin. We say generally PBCF, propeller boss cap fin. What is the advantage of using this propeller boss cap fin? So basically it is fitted to the boss. By using this, it improves the propeller efficiency, right? How it improves the propeller efficiency? Basically, see, as we all know that the propeller efficiency can be taken as TVA by 2 pi NQ. This is the formula. Okay, this is the thrust power, and this is delivered power to the propeller. So now what is happening when you are using this propeller boss cap fin? It increases thrust, additional thrust it is giving, right? And at the same time, it is doing some torque balancing 2 by NQ, because it is using the what you call vortex of the forward propeller. So thereby the PVCF is increasing the efficiency of the propeller. Okay. So the another concept is mu is duct. Okay. So mu is duct. That is just before the propeller. If you use this mu is duct, again it improves the propeller efficiency. How? Just by streamlining the flow. The flow is streamlined into the propeller and coming out of this mu duct, and it is going onto the propeller. So thereby it is propeller efficiency is increased, right? And fuel efficiency is good. So this can be fitted for new ships as well as existing ships. So this is suitable for high block coefficients and speeds less than 21 knots. Okay. So this is what generally we call retrofits, right? Retrofits means whenever this energy efficiency for existing ships index has come into the picture, what we have to do, already the ship has been designed and ship is working, right? Ship has been constructed, ship is working right now. How we can improve the energy efficiency by means of all these, what we call energy improving devices. So during the dry docking stage, we can add these things. Maybe we can use any other technologies in the fuel sector, and then thereby increasing the efficiency, energy efficiency. Now, coming to the nozzle propeller, many of us know also this nozzle propeller, it improves the thrust. Basically, it improves the thrust because the duct also will give you what you call additional thrust. Okay, so of course, again, in the nozzle propellers, we have different types like accelerated nozzles and decelerated nozzles. Accelerated nozzles are good for propeller efficiency increasing, that is additional thrust it will give, and decelerated nozzles are good for cavitation reduction because noise reduction things. So we have to see that what is the main function of our vessel, right? Accordingly, we can go ahead with the nozzle propellers. Now, contra-rotating propellers, right? As the name indicates, the two propellers are what you call working in opposite direction, contra-rotating. Okay, so the forward propeller is rotating in one direction, and after propeller is working in another direction. Okay, this is the contra-rotating. But advantage is how it works. Basically, see, using a contra-rotating propeller, advantage is, so we have the shaft like this, right? And we have a smaller one behind it. Okay, of course, shaft inside shaft will be there, and then gear will be there. Okay, so we have the forward propeller, we have the behind propeller. So the behind one is making use of the high vortex, whatever it is coming from the forward propeller, right? The vortex flow, otherwise it is being wasted just like that. It has been used by the second. And another feature is sharing of the load. Madam, is there anything? Okay. See, the entire load of the propeller is shared by two propellers. That means the load on each propeller is reduced. So thereby the propeller efficiency is good. Okay, that is what when we go for twin screw propulsion or triple screw propulsion or tandem propellers or contra-rotating propellers, the idea of that is the total load requirement can be shared between propellers. So then efficiency is good. Then propeller rudder transition bulb. Okay, so the propeller rudder transition bulb means this one. Whatever from the hub, directly it is like streamlined onto the rudder. That means what happened? The flow is onto the rudder so that the rudder efficiency is also improved, right? And lower rudder drag. As a whole, it improves efficiency. A well-designed streamlined bulb from propeller to rudder make use of rotational energy of the slipstream will give you more efficiency. This is all proven technologies, and then you can find it from the literature also, which I have taken from the literature. And then another thing is the pre-ducts. The pre-ducts also improve the flow onto the propeller. So thereby again improving the efficiencies, propeller efficiency. Yes, so far I have in nutshell given what all we can do in at the design stage, and then in the what you call dry docking stage or retrofit stages, that is energy improving devices. These are all few of the things available only, but there are many other things also, right? Now coming to the operation, this is very important, right? And especially important for the CII, that is carbon intensity indicator calculations and all those things. How energy efficiently we can operate the vessel. Now, these are all various methods or techniques you call, thereby we can operate the vessel in an energy efficient manner, right? Weather routing or speed optimization, draft optimization, trim optimization, then hull maintenance, propeller polishing, and optimum use of autopilot. Now, coming to this weather routing. So what is this weather routing? So weather routing is basically nowadays all these works are being done at what you call office, shipping company offices. Like suppose if you take Chennai, Synergy is doing their work from the Chennai office. Like that, their company's head office, they will do this, all these calculations. That is the reason nowadays there are a lot of job opportunities for the young naval actors also in this area, right? So weather routing means if you know, like the ship is going from, let us say from Chennai to Singapore, right? Based on the weather forecast and then wave data concerned with that, can calculate what route would be the better thing to reach Singapore, right? So that the fuel requirement is less. That means basically energy requirement is less. Okay, so thereby again carbon dioxide emission. So whatever it is, finally we should come back to the carbon dioxide emission. So we should reduce the carbon dioxide emission. That is what main goal here, right? So that is what weather routing. Now, what is the speed optimization? Speed optimization is a very important one, right? Again, example, I will tell you that, like, suppose the ship has to reach Singapore port by so-and-so day with the so-and-so time. The ship is going from Chennai, let us say. There is no point of going at very high speed, like with the 20 knots or something like that, and reaching the port 2 days ahead and waiting at the outer harbor. There is no point in that, right? So the planning of what is the optimum speed that will give me that, so that my vessel reaches on time. Okay, so that is very important. See, as you all know that each knot, yes, if you take our any resistance curve, for a very single 1 knot difference, the rise in the resistance requirement is high, right? So we should not think that 1 knot reduction, how does it matter? No, it matters a lot. So that the selection of the right speed for your journey, for your voyage, is very important. So that is what we call speed optimization. Okay, so rather than reaching ahead and waiting in the outer harbor and wasting again power there, better to go at slow speed so that you will reach on time, so that you can save the power, you can save the fuel consumption. That's what idea. Then coming to this draft optimization, suppose sometimes because you may not have a right load to go, then in that case, maybe can we optimize the draft? Suppose if you go at a little bit, maybe ballast draft, is it good? Or by changing again trim optimization, both will come under, together only, like draft optimization and trim optimization. Which trim is good, right? Is it trim by aft is good, or trim by forward is good? Or if at all trim by aft is good, how much trim by aft is good? All these calculations have to be done ahead, right? All this information the captain should have, right? So you should be able to take, or you will be able to take decisions quickly, right? So, but these things can be done even nowadays by using our CFD tools also. Okay, and then another important thing is hull maintenance. Hull maintenance is another important area where hull has to be like treated every time, like time to time. See, as you all know that again, fouling is one of the important area in our shipping industry, right? So whenever a ship moves, like seaweeds and barnacles and all come and attach to the hull, thereby the thickness of the hull is increasing, thereby the draft increases, thereby power consumption increases, fuel consumption increases, everything. So the idea of the hull maintenance is, yes, the hull is smooth so that the drag is less. That is what in nutshell. Okay. So here also there are varieties of number of techniques. You can use different types of paints where barnacles will not attract, right? So in the earlier days, they used to use pipernickel paints, which is like barnacles and all. They are allergic to this pipernickel paints, but now it is banned. Now maybe self-polished paints, another paints are there. Recently, I have seen that new technology has come using graphene film. If you can put the hull with the graphene film, so what you call, it will reduce the drag. Okay, so using various techniques, we can maintain this hull so that the drag is less. And the propeller polishing is very important, right? In the dry docking stage, we can see all these things here. So like is fully like foul or corrosion or cavitation, all these things will be there, or erosion, all these things on the propeller. So we have to check the what you call propeller polishing level using a Ribot scale. This scale is known as a Ribot scale. Okay, so we can use this roughness gauge and then see that our propeller is polished, right? So that propeller efficiency is good. So this is one measure during operation stage. Again, roughness, based on roughness, how the resistance, how the what you call reduction of the fuel is there, some calculation. And this is based on hull roughness, right? Based on hull roughness, the we can calculate increase in power. Okay, so based on this also we can think of as roughness is less, resistance is less, and then power consumption is less and fuel consumption is less. So that is what hull roughness. This is what I was talking about, the trim solutions, right? We can have a CFD calculation, right, ahead, and then we can see that various drafts and then trim, which is advantage. Like see, here it is there, good, fair, optional, like that, na? So this table, the calculations one, it can be done and handed over to the captain ahead, so that he can decide whenever it is required. Okay, so all these measures, whenever we are operating the ship, so we have to think. It's not like that, okay, this speed is available, I'm moving it, and no, it's not like that. So we have to work now consciously. That is what important thing for the sustainability, right? And then last topic is autopilot. Generally, we all think that autopilot means, okay, if you put it in autopilot, it will go on its own, then we are okay like that. But on the other hand, if you see, the usage of the rudder is high, then the power consumption is high for that thing, because it always keeps tries to bring it back the vessel. So the rudder has to, steering gear has to work, the rudder has to work. So then power consumption is more. So again, fuel consumption is more. So optimum utilization of the autopilot has to be, like, decision has to be taken, right? So with this, like, these are all various methods we can use in what you call in the operation of energy efficient operation of ships. So in nutshell, let me summarize like whatever I've discussed. I have given the requirement from the IMO, that is EEDI and EEXI, and CII, right? These are the requirements. For that only we are discussing all these things because it is a mandatory, right? At the design stage, yes, how best we can design the ship using all the techniques. Now we have advent of computational fluid dynamics. Yes, it has gone to the very high level, right? Even hull optimization also it can do on its own, right? So we can use that, but at the same time, the final, see, optimization, you can use CFD, but the final chosen hull form can be tested in model tested. Okay, that is one of the important things. Even EDI also makes it mandatory that it has to be what you call witnessed by the surveyor, right? So I myself visited HSVA and then Marine for the witnessing this model test as part of EDI. Okay. So that way we can do that design part, and then coming to the EXI part, we can use various what do you call energy improving devices. That is the thing. And then as far as operation is concerned, how best we can use this like wires optimization, speed optimization, and wires optimization also known as route optimization. Okay. And then what do you call draft optimization, trim optimization. Okay. And then maintenance, basically clean hull maintenance, and then propeller polishing. Right. So with this, I conclude my topic. Madam, now hand it over to you.
Mute.
Thank you. Thank you very much, sir. Am I audible?
Yeah, you are audible, madam.
Okay, okay. Thank you very much for the content-packed presentation. Means for me also it was a good enriching experience to have you, to heard from you. And now I would request our chief guest to provide his appreciation on the session.
Madam, we will take some questions from the participants, or before I close it, should we take the questions from the participants?
Sir, we will go with your appreciation and then we will take the question answers. Now,
Yeah.
I understand the question answer Q&A is it open to all, Mr. Bharadwaj? Is it?
Yes, ma'am, it's open to everybody. So if you want to ask a question, you can just go to the question box, question answer box, and you can post the questions there. Then I can put it in front of the panelists. We have one attendee. I'll just unmute him. He has raised his hand. Maybe he wants to ask a question.
Okay, Mr. Yogesh Jaisinghani has some questions.
Yeah, I have unmuted you, Mr. Yogesh. You can ask the
Yeah,
question.
okay.
Over to you,
Mr.
Mr. Yogesh.
Hello,
Mr. Yogesh, you can go ahead.
can you hear me, madam?
Yes, yes, we can hear
Yeah,
you.
we can hear you.
Good evening, madam. It is a pleasure to join this kind of a seminar. When we had and this I am attending in my personal capacity, when we had a changeover from single hull tankers to double hull tankers, then some vessels could convert their vessels from single hull tanker to double hull tanker. And there was a time when a window period was given for, let us say, some years for the, depending on the date of construction, date of keel laying in Marpole, and then the vessels were phased out. What exactly is the regulatory requirement as far as CII is concerned for main fleet vessels? Is there something that, is it within the gambit, or is there any requirement in which we are supposed to phase out those vessels, or some time has been given? Or, I mean, how do we deal with something that is not complying with the requirements, with the regulations?
Yeah, I think if anyone is there in this forum from the class, they can answer very well. If they are not, if nobody is there, like then I can answer also, right? Basically, the CII, that is carbon intensity indicator, it is
Yes.
applicable from that what you call from that January 2023, right? It is
Yes.
required for 1 year. That means entire 2023 year you calculate your carbon intensity indicator,
Okay.
and then you compare with the what you call the required CII given by the what you call by the IMO.
Okay.
As the year goes, like from 2023, 24, 25, 26, like that, they have
Okay.
given the requirements reduction. There is a formula again, CII reference multiplied by 1 minus x by 100. That x is the percentage. Is it 5%? Is it 7%? Is it 9%? 11%? The year wise they have given it. Okay.
Yeah.
So that CII, if you know the required one, and what is your attained CII, and then there is a ratio, that is attained CII divided by required CII, that there is a value.
Okay.
Based on that value, your vessel will be rated. Yes, it is A rated, B, C, D, E, like that. A
Okay.
means very good, fantastic, superior quality. Okay, sir. So A, B, C is okay, good. C is also acceptable. But suppose if your vessel is in D and E for the next consecutive 3 years, you have to come up with the what are the measures you are going to take. You have to come up with a plan. You have to submit. Okay.
Okay.
This is what at present on the CII.
Okay. So if it does not meet within the 3 years, then it is supposed to be phased out.
That's true, to tell you frankly, since your question is very genuine. Since it started now only, people will come up with all these things. If it doesn't meet what has to be done and all, again, IMO and then class and all come together and all those things. Right now, we are in that 2023 period. Maybe in the 2024, they will check for your fleet or for your vessel.
Okay.
What is your CII for that?
It is to be seen in the start of 2024 how the vessels have performed.
Exactly. So yeah, for
And then-
2023 requirement, they will check.
Okay. And then after that, if it is not meeting, then a call will be
That he has given the 3 years time.
A,
sir.
B, C, D. And
Yeah.
if it is not meeting, then they'll be phased out.
Exactly. That decision will be taken. It's not like just straight away you are saying and I'm saying. Maybe by that time people will come up, because that is a 3 years time is given, na? So people will come up automatically.
But this is not compulsory in application. It is recommendatory in
No. I think CI is mandatory as part of SEM.
Mr. Apurva Karb also wants to speak.
Yeah, please. See, another thing I want to make it here. Maybe other senior members from this forum also, they also can share, because we should not think all the time whatever I am saying is right. See, of accepting giving lecture also to share what I know. At the same time, I want to learn from yours also, right? It's not that, yes, if anybody is known on this topic, he also can share. Yeah, if any question, please, sir.
Sir, our next question we have from Mr. Janoy. So I'll just unmute Mr. Janoy.
Yeah.
So you can ask the question, okay? So, Mr. Janoy, you are unmuted. You can ask the question if you want.
So Janoy, sir, I will read out the question for.
Yeah, please, madam.
Is it feasible to fit the propeller boss cap fins on an existing propeller, or is it a type of propeller? That's his question.
Is it possible? Yes, PBCF can be added to the existing propeller. That is what the technology, right? Where they will design your PBCF, which will shoot to your boss diameter. So it will be added to the, is the retrofit. It is a retrofit. It can be added to the existing propellers.
Okay, sir. Now I'll just ask Mr. We have one more question from Mr. Kishore.
Yeah.
And we will take in Mr. Apurva and Mr. Shashi.
Yeah, no problem, sir.
So Mr. Kishore is asking, what is our view on sail assisted ships?
Yeah. Sail assisted ships. See, to tell you frankly, in the given topic, based on the time constraint, I have discussed only like mostly hydrodynamic related aspects only, right? And this topic is so vast. Like, suppose if you take on fuels itself is a big area again, right? We can think of hydrogen fuel, we can think of methanol fuel, LNG, all these things are there now. So methanol is coming from 2024. Okay, like that, there are so many things. Now you are talking about sails, kite assisted, then what you call Magnus effect, wind turbines, right? And solar panels. All these things are there. Yes, you can use it very well. In the EDA formula, that option has been given. When you get power from these assisted ones, auxiliary ones, it can be subtracted. In that there is a formula. In that formula, there is a minus on top. So when you get the power from these additional sources, it can be subtracted, and then very well your EDA will be less. Yes, you can consider anything you can consider. That all depends on the designer now. See, that's what I say now. The young naval architects and senior naval architects who are all working in this area, they should be more vibrant than the previous old naval architects. Okay, so somehow they have to make the design energy efficient.
Yeah, I would like to add here that
Yeah,
now there are so many ways and means while selecting your equipment fit, whether it is main engine or other systems and equipment. There are provision to ensure that the green requirement is met. So that is nowadays it's most of it's the responsibility of the designer to ensure that all the norms we are, Prof has already mentioned as met while we are designing itself. And there is a lot of provisions in the life cycle management of a vessel which is already existing and which has to be retrofitted. So people are studying the requirement of retrofitting and adding additional facilities in the existing vessel to ensure the green concept now. So it, as sir said, the designers has to be more vibrant and more actually keeping their ears open to the new norms and new policies coming in. Because there will be a point in time where we need to completely shift from the existing norms to the whatever policies are coming in. So there is a question from Sashibhushan Pappu.
I think it's not a question, it is like adding. He is adding to our point. Okay, he is telling that CII rating of D for 3 years requires SEM update. Rating E required immediate update of SEM. That's what adding point. Thank you, sir. Any other questions?
That's Lalita Devi is having
Lalita Devi, I think Lalita Devi is my previous student only. I think so. She is from, I think, SCI, I think. Sir,
okay.
Can you please tell us about gate rudder? How much improvement? See, this is what I'm saying. Any modification, any appendage, it's not like straight away from this or this. No, it has to be verified either by a numerical approach or by a model testing, right? And one more thing, actually many people will ask question. I have given number of methods, correct? If you use PBCF 5%, if you use this radar, that 5%. So a naughty boy or somebody can come up with, sir, if I use all the things, will the resistance will be 0? No. Okay. So again, we have to check that the cumulative effect of it, right? So straight away it cannot be decided or tell like this, Lalita Devi, right? It has to be verified, because since you are asking a type of special radar, a gate radar sort of thing. Okay. Right.
There is a question from Prem Kumar Krishnan.
Yeah. Is 3% CO2 emission by ships include defense ships all over the world? Sir, I think this is the data by IMO given, right? I don't think defense ships they might have considered. We do not know exactly. It is by shipping industry, right? 3%.
So now even though in the defense area, there is no requirement from the IMO, but many of the defense navies are asking for this particular provision, because we need to, whether from the defense point of view, whether it is required or not, but as a with special norms, all the navies are asking for this provision actually.
Correct.
We are actually dealing with some international navies where they are specifically asked for this 3% CO2 emission for the naval vessels also.
Correct. Maybe that, see, as you have said, no, madam, this IMO requirements and all applicable for the commercial shipping only, where they're saying 400 GT and above and all those things, right? But as a national policy also, our country can take decision, yes, whatever ships we are constructing in Indian Navy or whatever it is, or Coast Guard or whatever it is, yes, we have to meet this means it is applicable. Okay. And Swapnil Sankpal is giving suggestion. Yeah, he is my student. Good, Swapnil. Yes, we have to think of fuels, right, ahead. Yeah. Then, yes, now there are n number of technologies are available now, right? It's not that, but there are some other issues like how do we do the bunkering? Suppose, let us say hydrogen technology is there. Yes, engine has been made, prepared. Yes, it can work on hydrogen. Suppose the ship will come to India, Chennai or Vizag or Mumbai. Do we have hydrogen bunkering facility? That is important thing, right? Even ammonia, NH3 or even methanol. Yes, we are in that stage now. I think my idea is, I think LNG bunkerings are coming slowly. Okay, but as other fuels and all, maybe it will take some time, because bunkering is also important, na? Yes, you have designed the ship, you designed the engine to run on a different type of fuel, right? But how do we take the fuel bunkering in different ports? That also has to be established. I think Yogesh is asking Sashi Bhushan sir's contact number. Okay. Maybe he can provide in the chat box if he is willing to share. Okay, any other questions? See, generally in my class also, I generally tell number of times. First of all, we should ask questions. Whether the teacher or other speaker will be able to answer or not, secondary. By asking, what happens, we ourselves will get knowledge, right? Suppose if the speaker do not know, he will learn and update it. Okay, that is very important thing. Actually, many of you know that even our Indian tradition also, all the knowledge has been transferred by question and answer only. Okay, you take Upanishads, question and answers. You take Bhagavad Gita, question and answers. A question has to be asked, and then other side, he will answer whatever he knows. Nothing wrong in it, right? You can validate it all the time. The answer has to be validated by you only, right?
So, sir, we'd like Mr. Apurva. He has been raising his hand for a long time.
Yeah, please.
So
I
maybe
see
if
some.
he wants
Please.
if he can go ahead and speak. So, Mr. Apurva, you are unmuted and you can speak.
Oh, thank you very much. Thank you very much. Yeah, Professor Raju, I am really thankful to you. The presentations, I think what you have rightly mentioned, that this topic is so vast. It is it's very challenging to cover in 1 hour time.
Yes.
I think I'm sorry to say that what you could have done possibly is you could have scope of the presentation you could have mentioned at the beginning, because it's so vast. Because many things are really missed out. Firstly, the first question which was asked by one gentleman. Before that, the phase out. See, in this regulatory aspect domain of this particular energy efficiency area, there is no phasing out date. It is a natural death. If you cannot meet the requirements, your phase will be phased out. But there is no, like other regulations, they have got a phase out date, like double hull tanker, single hull tanker. They had a particular phase out, but here it's not like that. It's a natural death unless until. Another thing is you have to be, people have to understand what is EDI and what is actual the CII, what is the underlying difference. That is what needs to be understood by everyone in our industry, because EDI is a very ideal condition when there is no wave, no wind, and absolutely calm sea. But in case of CII, it is the actual measure of the fuel consumption in the actual sea conditions. So these two are quite different. You may achieve EDI, but you may not be able to achieve CII. Though CII at this point in time, it is only is sort of a trial kind of a requirement now. IMO has still not closed it up because they have given 3 years time, and if you cannot meet consecutively 3 years, then if suppose if that happens to majority of the ships, then IMO of course will be forced to rethink like what can be done, whether it can be relaxed or not. That's another thing. Another thing is there are many innovative things which possibly you have not included yet. Like waste heat recovery, and that's something I mentioned about the solar
power. That's what I told you, sir. It's a vast topic. It's a vast and covered in 45 minutes.
And those things are there are particular technology, there are particular method that how you can measure. Suppose I fit something waste heat recovery, but how do I prove that it is improving my EDI? Because that is also a very tricky thing. There's a lot of technologies are involved in that, and you have to prove that proving of that my EDI has improved or my EUI has improved. That's a big challenge actually. Technically, I'm saying it's not a simple, straightforward thing. Another thing is regarding the SIMP. That is also basically operational. That is not in the design. Another thing is the fuel. Of course, the newer fuels are coming. That is another big story. There is another big story. Another thing is people are asking how can I improve? But as I said, that EDI is a no wave condition. Now you have some device, suppose the energy efficiency device, which is useful for when you have a wave condition, which is not useful for a normal calm water condition. So it will not help you in the actual getting the EDI, but it may help you in improving your CII health. So a lot of intricacies are involved in each and every step, and it has to be proved and established through testing and also through the sea trial. Another very important thing, Professor Raju, that possibly needs mentioning, that in the case of EXI, when it's existing ship, the many ships in actual practice, you have seen the trial results are not available. Sea trial results when vessel was built. Sea trial not available. So once sea trial is not available, how do we know what is the trial speed? Because in the EDI, it's a new ship, you are doing a sea trial and you are getting the speed. But in the case of EXI, that data is missing. Now, how will you calculate the EXI? The basic requirement, the one primary important requirement is the speed. So then what is the other option? So for that, IMO has come out with an alternative option that you can do the CFD analysis and then can establish the speed. And that also is not so straightforward. It's really a very
reference has to be selected in a proper way.
Very cumbersome process. And also another issue is the safety. A lot of safety issues are involved in this area. When you are making a ship energy efficient, you also have to be very careful about whether you are encroaching in the safety aspect. So that is to be, because maneuvering and all those things, because you have got a very less power, then you're maneuvering will be a big problem. Safety of maneuvering, safety of controlling your problem. So safety aspect is also another big area. So that's why what I would like to suggest, if you take up some further presentations, you can segment it, because this particular presentation, when you started with the EDI, EUI, I was slightly upset because this is a topic of 10 years before, when it was just awareness was required. But now these things are gone. Things are already there existing in the last 10 years. So people are demanding many other the technical issues. They're asking the questions. That is what is my general, because I had been working in class. I am not now, but I was quite involved in various type of research in this area. So in the international forum also. And also I'd like to ask one specific question, because you are now representing a university, AMET University. I'd like to know what the universities are doing in these areas in Indian university. Are they really doing anything worthwhile? Because these are all following the IMO regulations and following the industry. But what we are doing, that is, we like to know.
So your actually the point is well taken, basically. So this, as we told also, it cannot be taken even one day, even 1 month also, right? Because the topics are so vast, and different type of expertise is also required. Suppose I'm being a naval architect. To tell you frankly, I'm not that aware of what you call waste heat recovery, how it works, and all those things, right? Again, we need to take what you call, maybe our Bharadwaj can think of a marine engineer who has worked in the class, and then he's having knowledge. There again, we can have one more session there on the what do you call engine part, engine related side, right? That is one thing. As you said, fuels itself is a vast topic. Any fuel you take, we can talk on our side. Okay. That again, that is another expertise, right? And another thing you told, that there is no end of that innovation topics that can be discussed in this forum. Suppose, let us say, I have given something, whatever is available, correct? Yes, anybody can come up with a new thing and then explain it also. Okay. So, right, your point is very valid. See here, the idea of this giving also, like there will be youngsters. First, we have to create the awareness of, yes, EXI has come up in picture now, only this 2023 January. As you told, EDI was 10 years old, 2013, right? But we should be aware of this. Yes, we should know it. And as you said also, EDI, that formula itself, if anybody sees, they will they will not be able to understand straight away in the first instance itself. Okay, there are so many terms in that, and then there are so many coefficients inside. All right, the calculation or whatever it is. Again, as you said, na, it will go under as a consultancy area. Like suppose class will take, you know that you worked in class. The classes are having advisory divisions for this only, right? Maybe IRS, DNV and all. See, I worked in DNV in 8 years. So they are experts in this. Group of scientists will be there on that. Whatever point we tell or project we give them, they will work on that, right? So thank you very much, sir. We will maybe Bharadwaj can consider in the next lecture subsequent. So we need not leave here itself, correct? Maybe next time we can take a working what you call surveyor or a chief surveyor in the class. He can talk about what are the regulations, what they are doing it. Okay, that way we can go ahead, sir. Thank you, sir.
Sir, just to add to one of your just observations regarding academic work, sir.
Yeah.
As you know, academic work is getting limited only because they have to do it experimentally only. There are some good numerical groups which are working in various places, which Dr. Echada is also aware, regarding all these hydrodynamically. But when it comes to experiments, only the IITs are able to do some experiments, and to some extent NSTL. So both the IIT Madras and IIT Kharagpur, there have been a group of young faculty who is trying to work on energy saving devices in particular, but they are focusing only on energy saving devices, including their maneuvering capabilities and seakeeping capabilities. As I said just now, I know a few youngsters who are working in IIT, young faculty who is working in IIT Kharagpur was just completed some projects and taking it forward. But to a real ship case, not much has come from the universities, and that is a bridge that we have to build between academic institutions and the practitioners. So I think there was one request from Ms. Lalita Devi regarding the presentation. This lecture is available on YouTube if you just go and search, so we can just do that. Further to chair for the further questions. With the permission of the chair, you can just see the further questions. There are two other questions, as I believe, which I can please. One question,
Go ahead.
Yes. One question was again by Mr. Sashibhushan regarding CII. Deadweight is constant. Is it appropriate, or should it be the actual cargo deadweight carried instead of constant deadweight figure at summer load?
No, actual capacity what they're carrying.
Okay. Probably clarifies.
Yeah.
There's a question by Mr. Mahesh Kawade. Has IMO issued any guideline pertaining to the use of solar energy as an energy saving accessory to main propulsion?
I don't have an idea on that, but all these additional requirements can be used in the formula. Yes, they are given, all these things can be used in the formula, in the EDA formula.
Mr. Kalgarki, one senior naval actor, he also wants to make some observations.
Yeah.
Probably he can be added to the panel.
Yeah.
Kalgadgi Sahib is not a senior naval actor. He is chief surveyor of IRS.
Yeah. Yes. Please, you can just
Thank
add
you,
it
sir.
to the
Please,
panel.
go ahead, sir.
Please go ahead, sir. Yeah.
I think we
please,
have
sir.
to allow him to,
Yeah.
that permission has been
Please,
given.
yeah, permission has been given. Sir, please, sir. Please, we want your observations. Sir.
Yeah, can I speak now?
Yes, sir, please, sir.
Yes, sir.
Yes, before I say a few things, let me compliment Professor Raju for his presentation. What I would like to say is, yes, I'm not a naval architect, but I have had experience with class for a number of years. Notwithstanding that, I think to some extent, I agree with what Mr. Carr said, which is not to take any credit from you, but some of the things which there is no straightforward solution.
Yes.
Like what you apply for a specific ship, it cannot be applied for some other ship, though
Exactly.
it may be a sister ship, because each ship, the whatever retrofit or whatever design changes you want to make, like you propose number of modifications, each modification has to be proved for a specific ship, and then you deploy them to achieve maybe 3 to 5% or a little bit more, and then only you can succeed. It is not, there is no one remedy or recipe for all the ships. Take a ship, study it, and then what fits it, then only you go forward, and then it cannot be just carried forward to the next ship. No, it's not that simple. And phasing out and all is not that today it doesn't meet and tomorrow it just it stopped at the port. It's not that a simple thing. There are a number of things which the ship owner is given opportunities to improve upon. So please don't be under the impression that immediately it will be phased out, because there are CII, A, B, C, D, E, 5 categories are there. And A, B, C, D, A, B, C is just, I mean, it's like saying that you made the grade, but D and D, they are given opportunities. E is, of course, definitely a black spot, but D, you are given a time to improve upon. So what I want to emphasize is that it is CII is not that straightforward as EDI, which is at the design stage. And for operating index and CII, you have to really study the ship, its ship lines, and what is the power, how much you can reduce, and what Mr. Carr said, there are safety requirements are there. You should not fall on the minimum power requirement from the steering point of view. So all this, there are several factors which you need to keep it in mind before you even think of deploying them on a specific ship. So this is what I would like to observe. Once again, thank you, Mr. Raju, for making
Thank
this
you, sir. Thank you,
presentation.
sir.
Though, yes, I mean, because I was in thick of this when it first time it came into 2013 or a little bit
Yes,
before
sir.
that. At that time, yes, definitely it was an interesting topic, but now it has been carried forward and made applicable for existing ships, and definitely the CII rating is going to be implemented very soon, because as everyone knows, the whole idea is to achieve the CO2 index. That's the whole purpose. Thank you very much, sir. Yeah.
Thank you, sir.
Thank you, sir. There is a request from Mr. Sashibhushan to make few points.
Yeah, please ask him, sir, to add.
Mr. Bharadwaj, if you could add him.
Sure, ma'am. We'll just add him to the panel. I think he's added to the panel, madam. Mr. Sasibhushan, you can just make your remarks.
Hello, sir. Am I audible?
Yeah, you're audible.
Yeah,
sir.
audible.
Yeah. Raju, sir, please don't call me sir. I am your student also from AMET only, actually.
Oh, okay, because I go by
First,
name. Okay,
yeah,
nice,
first
nice.
master's batch, actually, from
Okay, very good.
AMET. Anyway, sir, for the last 1 year or 1.5 years or so, I've been working on EXI and I've been involved with the CI. I also, in a marginal manner, I've done close to 200 plus ships EXI calculations.
Oh, very good.
So, yeah. So, sir, a couple of points which
Yeah,
I
please add,
thought
please
I
add.
should. Yeah. One is actually there is a doubt in my head. I'm not even sure yet, but I think deadweight or the capacity in CIA is a constant factor. It is not a variable thing. It is not actually the deadweight carried, which is very surprising for me. It is the constant deadweight of a ship, like the summer load or deadweight or whatever. So I feel that that's something which has to be changed because it is not actually reflective of the ship's performance. And anyway, second point, sir, regarding some people were saying minimum propulsive power requirement, and you can't and go below a certain power, otherwise your maneuverability is hampered. So regarding that point, if it is EEDI stage and you're doing a permanent power limitation, you have a regulation in place which prevents you from going below a certain limit. Second point, regarding in EXI, it is actually a overridable power limitation. It is there to so that in case if you are having emergency situations, for example, adverse weather or piracy or saving life at sea, you can and derate your remove that limitation and go above it, or go to your max power or whatever is the safety requirement you have. There is of course an issue with that because some of the ships are going for what do you call all mechanical limiters, which is basically keeping a stop on your governor or preventing it from going to higher powers, and thereby you are not able to do it, and it takes you half an hour or 15 minutes to delimit. So those are things which have to be taken care of for our ships, and there are a lot of options in place. Yeah, I'm sure, or there can be further sessions here, or you can consult any of us, any company to get solutions for it. And as sir said, there are every solution is a ship specific solution. Each ship is a unique story onto itself. And yeah, that's it from my end, sir. I also wanted to know what is your opinion on auxiliary power components of a ship. Are you seeing? Do you believe there is any naval architecture solution which can be done to reduce the auxiliary power requirement for a ship? Because that is also a major component in EEXI. So
Correct. See, this auxiliary power things, my feeling is like we can go ahead with the other alternative things like maybe solar power, wind power, and all those things. We can use it for that other auxiliary purposes like lighting, other thing, like galley and all those things. So in that case, we are reducing the fuel consumption. Okay, so thereby carbon dioxide emission, the requirement of it.
okay, sir.
Right.
Fine, sir. Thank you.
Thank you, Sasibhushan. I am very nice.
Yes, sir.
Good. This is what happiness a teacher will get generally, you know. So,
Yes.
thank you. Thank you very much.
Meeting your students in the forum, it's a really good experience.
Thank you. Thank you.
Okay, so Professor Raju, if you'd allow me, I'd just like to add a few
Yeah, please,
points.
sir. Please, sir.
Yeah, my side also. So I'm sorry, my camera is not working, so everybody cannot see me. But just to introduce, I'm Rajneesh, and I'm a naval architect, and I am also working in the field of green technologies, and so earlier associated with a lot of.
Sir, you're from Vedam?
I'm from Vedam. That's correct, sir. I'm from Vedam.
Very good, very good. I know. I think. Tell me, sir.
And so earlier working with ballast water scrubber, and now since the industry now moving towards EXI and CII and ESD.
Correct.
Sir, also, but my point of view is little bit, sir, cynical on this. Allow me to just
yeah,
look
please.
at point of view also. So all these new technologies and new initiatives and all that which is coming in, we have to take this with a little bit of pinch of salt. Okay. Because my experience is a lot of these things are being pushed off by many developed economies. You see, as you said, rightly said, shipping is a 200, 250-year-old, 300-year-old industry. And now what new to sell? So many of these initiatives and innovations, they are being pushed upon to IMO by this developed economy because they have nothing else to sell now. I'll give you an example, sir. There's a very reputed engine maker, and many people talked about EPL also here. So, very reputed engine maker, and when we asked them for a proposal to do this EPL, in the proposal itself, they mentioned that it's a 20-minute job. I mean, they say that we need just 1 hour access to the engine for doing this job. And when we move to the next, to the cost part of the proposal, they will mention $2,000. So as you mentioned, when of course, one way is we can, as Indian, and our needs are different from the industry. I mean, we have also have to look at our interests and how it doesn't get compromised by too much focus on the in the efficiency part. So there are two ways to do about it. One is we influence IMO as much as we can to take these, or there can be some way of differential of how you go about implementing these, and maybe there can be a different set of criteria or different set of options for different kind of flags. That is one way. And of course, when we formulate our own local regulations, then you have to keep in mind our own requirement, because many of times, sir, when practically working on these options, I see there's a lot of there are many things which are being asked by these regulations which are not really required. Okay. If you talk about, I'll give an example of scrubber. Okay. Now scrubber is a technology where you sort of take out the SOx from the fuel.
The engine exhaust.
From the sir, the amount of energy. So how it works is you push the seawater from the bottom, install a scrubber, put water into the scrubber, so that it can scrub out the SOx in the smoke. Now the amount of energy you are spending to pump up the water from bottom of the ship to the top of funnel, that is in generating more SOx than actually the SOx which you are cleaning. And what are you doing with the SOx? Instead of putting it in air, you are putting it in water. Okay. So, and there's a lot of lobby which is going on. So what I'll say is, it's very good to, of course, as long as efficiency is concerned, definitely we should go for it. But as far as this compliance and trusting upon many new regulations, we should be a little bit skeptical about it, and on the at least at the national level. That's the sense I have working on these projects. I just thought I just put forward my point of view on this forum.
Good, sir.
Yeah. Yes, sir.
Thank you very much. I think we have answered all the queries in the Q&A column. Shall we proceed with the concluding?
Yes, ma'am. I think we have
yes,
yes,
ma'am.
Next agenda.
You can proceed, ma'am.
Okay. So now here the question answer session also. Now I would request Mr. Dr. H.N. Das to provide his appreciation on the session.
Thank you, madam. So now you understood why I asked to give after the question answer session, because it reduces my job.
Yeah, right.
So my work is already done. I appreciate Professor MSP Raju, compliment him for giving a very informative lecture, and in a very short time he has communicated so effectively that the later interaction and question answer actually is a proof that how well he has communicated to all this audience, and there was a lot of interest generated. So I thank you very much, Professor Raju, for giving such an informative lecture. See, advantage for me is that I am not a naval architect, so I can say anything. You may have some limitation because of engineering and all, you may not say something, but because I am not a naval architect, I can say anything. So I will say few things about your lecture. See, you talked that statutory requirement is to reduce the emission. It's very good. But on top of that, we should see it is our responsibility towards the next generation to reduce the emission. So
Correct,
it is not only a statutory requirement. We, at my age, I am an old person also. So at my age, I should see that it is our responsibility to the next generation also.
Correct.
And as far as technologies, you have nicely brought out many technologies which can be used for reducing the carbon emission. Very good. Of course, we should go ahead with all this. If the technologies are available, we should go ahead with all this. But the question is that there may be something more also. Like later it has come that alternate fuel, maybe fuel cell, hydrogen as a fuel.
Correct.
Yeah, wind energy, solar power. All the possibilities can be looked into. And because I am not a naval architect, I can again press on these things that you look beyond naval architecture also to reduce the emission. Particularly like contra-rotating propeller and all you have said, I have not seen much of use of contra-rotating propeller. Maybe it is there. Yeah, maybe it is there, but for a ship and all, I have not seen it is much used. And I really don't know why it is not used. So all these technologies you have discussed should be used, and it's beyond that also. I will request all these forums, and it is a very nice interacting session. Actually, I am very pleased to see that kind of interaction. And as it was rightly brought in, that it is not the end. It may be giving the beginning, the initial appreciation. We may take on as a series of lecture. In fact, your university also can think about it, making a short-term course for a 7-day or something that all these participants will, because it is such an interesting topic, there will be a lot of crowd available. With this, I think I thank you again, and I thank Dr. Bharadwaj Iyengar and all the organizers to invite me for this session, and I am really pleased to be here. Thanks, Mrs. Sapna Madam also. Thank you very much.
Thank you very much, sir, for your good wisdom. It's a being non-naval architect, you have the advantage and you can speak out of your heart, which can be included in the naval architectural calculations and forms. Thank you, sir. I would like to summarize this as Professor Raju has brought out the two main aspects, that is the energy efficient design and energy efficient ship operations. Almost, I think, the major points covered in totality. Now we know the norms, and in future we need to ensure that the maritime operations are green and less harmful than environment. Maybe as on to date, we may not be having much of a data, but statistics will come out with more studies or more researches being done in this area, and more ships getting into whatever outcome of the researches implemented in the ships. So if we look at the points he covered, gives us a start. We can have a separate session on maybe alternate fuel. It is altogether a different topic which can be taken up for another session. And there are equipment fit, like which ensures a lesser emission. So there can be separate topics which is connected to this particular energy efficient design and operation of the vessel. And I'm 100% sure that the participants also contributed well to this topic, because we are having different people from different areas who work in this energy efficient operation and design. So the participants also made this session very interactive, and thanks to you all for that. Overall, it was an enriching experience for me also to coordinate the session. As a session chair, I thank INA organization for giving me this opportunity to be part of this technical section, and thank you all.
Thank you, ma'am. In fact, the session was so lively that, in fact, we had a last-minute suggestion also by one of our participants that we should consider energy-saving device for inland waters also, not just sea. Suggestion taken. With this, I would move to the final part of my pleasurable duty today, is to thank all involved. My first thanks is to Chief Guest Dr. H.N. Das, In fact, it was quite a late request actually when I requested Dr. Chandas, and immediately accepted an invitation to be the chief guest for the session, and he gave interesting insights. He tells that he's a non-naval architect, but I'm working with him, and his knowledge is no less than a naval architect in this field. Thanks, ma'am. My next thanks is to Mrs. Sapna Dipu. I contacted her maybe after a decade or so, and she readily accepted my request to be the session chair, and she has coordinated this session well and summarized this session. And thanks to the speaker, Professor MSP Raju. He has brought in a very vast topic, and he has given initial insight for whomever wants to understand more. This will certainly, give a very initial insight to further works or further knowledge or further interest in this area. Thank you, sir, for the very comprehensive lecture. And all the participants in the question answer session, particularly our senior professionals, Mr. Apurvakar, Mr. Kalgatti, and Mr. Sasibhushan, who added very lively and brought in a lot of perspectives, and Mr. Rajneesh, who is also the executive council member of INA, who brought in this perspective and made the question answer lively, and all the other attendees. And today's attendance was quite large. I can just say around 45 people participated, which is quite large. So I thank all the attendees who made this session lively, and thank you all. Thank you all. Thanks for
Thank
me.
you, boss.
And
Thank you.
session get concluded. And session get concluded. Thank you. Thank you.
Dear GBA, it's my pleasure, privilege, and honor.
Yeah, beg your pardon? Yeah. I think still there is a request by Mr. Subhakar Dandapat whether we can look at these issues for inland shipping. So perhaps with that answer by the panelists, perhaps we can close the session today. Any comments on this from the panelists regarding using these regulations for inland shipping?
See, it's not written anywhere that you have to use it for this only, something like that. See, IMO says about what you call international shipping, basically, correct? So any ship which is higher than 400 GT, something like that, they are given one broad thing. Even CII is above 5,000 deadweight, something like that, they are given. So suppose if inland water transportation division in India, if they decided, yes, for all my inland water vessels should have energy efficiency or energy efficient devices, nobody is going to stop. Actually, it is indirectly is favoring the country, na? So it is good. It's good for the environment. Yes, people can think of, but the thing is like inland water vessels dimensions and all. If you see, they're very small, something like that. Okay, so but if somebody is investing on it, generally people what they will see, what is the return on investment, correct? Na? ROI, economically, financially. Okay, based on that, it depends on that. Nothing wrong in it. Suppose if somebody wants to go for energy improving devices, yes, we can go ahead.
Just to add to that, as Mr. Rajneesh was mentioning, one of the things that we should focus on is the local laws. And as my senior professionals have told, when EED or EXA came, it itself came with probably 2 decades of research, which finally translated into rules.
Exactly.
So that amount of research probably AMET University and other universities can start with to later convert it into some sort of regulations which are actually required for the country. Taking chief guest's remark also that we should, not consume too much in or future these things, we should not consume it today. So taking that into consideration, under current needs, we should form the laws. Probably universities can take a lead in research to see what form such regulations should be.
So
That's my suggestion, and with that comment and with the request for questions, perhaps we can close today's session.
Correct.
And thank you all for coming on a Saturday and joining us and enlightening us. Thank you, and the session can close. Thank you.
Thank you all.
Thank you.
Bye.
Thank you very much. So I'm just terminating the session. Thank you all.
Thank you.
Thank you.
Bye.
Bye.